Welcome to my video. I am Suhas Bhagate from D.K.T.E's Textile and Engineering Institute, Ichalkaranji. I am demonstrating the project done on machine learning using Python by using online tutorials from Skyfi Labs. We are working on a project of Boston house price dataset. On that we are predicting the price of house. We are using that Boston data set having total 13 attributes. Total 506 rows are available in this data set. So initially we import the necessary libraries for this project. These are NumPy, Pandas, Matplotlib, sklearn, etc. We load the Boston dataset by using this command load Boston. These are the 13 attributes whose information is given in the dataset. We have copied these values of these attributes into data frames. It shows individually we can check the values of each of these attributes. Target, it represents the price of house. We can perform the normal operations on these values of attributes like getting the maximum and minimum values. Then we have concatenated the values of all these 13 attributes along with the target price in a single data frame. Then rounded these values up to 2 decimal digits. Then we calculate the correlation between these attributes with the target. We use Pearson correlation for that. This graph represents the correlation between these 13 attributes along with the target. From this we can find that LSTAT, which represents the percentage lower status of the population, is highly correlated with the target price. So we are going to use this attribute for the prediction. So LSTAT is used and stored in this X. Target is the price of the house into Y. We have printed some values of Y, first 5 values. These are these values. This needed to normalize these values in the fixed range. So we have normalized them on the scale of 0 to 1. So for them the respective values between 0 to 1 are shown here. Then we call train test split function, pass these values to that function. After that we write the error function and update function. Then we write the gradient descent function for performing the linear regression. We pass the values to this gradient descent function. The initial value of m 0.9, initial value of c is 0, learning rate is 0.001, 250 iterations we are expecting. Error threshold, the maximum allowed error is 0.001. After calling this gradient descent, we represent the map of this. So we get this like this. This is the curve for it. Then we make the animation and the video of this. Later on, what is the value predicted by this algorithm and the actual value. Based on that we calculate the mean squared error. Here we are getting the mean squared error as 0.0162. In the data frame, we represent the actual values is the value of x, the target value, and the one which is predicted here is shown in the third column. We plot a graph for this. All these values are between 0 to 1. These are in the normalized range. We need to convert them back into the real values on the real scale of $1,000. So these are the actual values for the respective values of x. The target value is this 19.8 in this case. The predicted one by our algorithm is 22.97, like that. So here the mean square error is 0.0162. We can change the attribute selected here for predicting the cost we have used. The one which is highly correlated with the target price was LSTAT. We have used it. Now we use the second attribute, which is next highest value than this LSTAT correlated with the target value. We check it step by step how is reflecting into the other values. So this is the graph. In this case, whatever the graph we have got, it is directly proportional. In the previous case, when the attribute LSTAT was used, it was inversely proportional. Here we can find the mean square error. It is too high compared to the previous one. It is 0.0301. So it means it is not too accurate by predicting the value. One more case we check. We use the attribute which is least correlated with the target, with CHAS. Check the other values. Check this graph. Is least correlated one. The mean square error is too high. So the attribute LSTAT, it used the maximum accuracy because the mean square error found there was the minimum one. I completed this project by using online material provided by Skyfi Labs. I am thankful to the Skyfi Labs for providing the material. Thanks.